We have looked at perpendicular lines in the past. Think for a moment about what makes two lines perpendicular. Okay, most of you probably did this gesture where you cross your arms in front of you like, no. And what most of you think is that two lines are perpendicular because they intersect, which is true. Whoopsie, let's do math, let's do draw. They do intersect. But they intersect in a very special way. They intersect at a 90-degree angle. Or a right angle. Okay, so again, just like on our last video where we talked about what we kind of took parallel lines up to the next level, we're going to take perpendicular lines up to the next level. All right, so I want you to look at these two lines. I want you to write an equation of each of these two lines, and then we're going to look a little bit more closely at them. Do that right now. Okay, so for this first line, if I write an equation of this line, they gave me two points. So for the first line, let's call this line A, we'll call this line B, okay? So if I draw my slope triangle between the 2 points they gave me, I go down 1, 2, 3, 4, 5, so minus 5 over 3, and then its y-intercept is negative 6. So line A of x, function A of x, is negative 5/3 x minus 6, okay? Now let's look at line B. Line B, if I draw my little triangle here, whoopsie, sorry about that, I go up 3, right 5. So, and my y-intercept is 4. So B of x is 3/5 x plus 4. So take a look at those and see what is something that you notice immediately that's easy to change about them. All right, when I look at them, I see that their slopes, well, first of all, I see that one is positive and one is negative, which makes sense. They won't cross if they're not going in different directions, right? If they're running, well, they could cross, but they're not going to cross at 90-degree angles for sure, so they have to have opposite slope. So first thing I see is opposite slope. Okay, so their slopes are going in opposite directions. The second thing I notice is that it looks like the slope 5/3 and 3/5, it's flipped. And if you recall, the word we used for that is reciprocal. So reciprocal means we flip the fraction. Opposite means we flip the sign. So we're going to flip and flip. Everything we can flip on this thing, we're going to flip it. Okay? So what makes two lines perpendicular in everything up until algebra is that they intersect at a 90-degree angle. What makes them, we're going to refine that definition now to say that what makes them perpendicular now is that they have reciprocal opposite slope. All right, so let's graph any line that's perpendicular. So what do I know about this line? I know that this line, let's call this line A. So I know that A of x is 2, 4, and so the slope is 2 over 4, which simplifies to 1 over 2. 1/2 x, it goes through negative 4, minus 4. I want you, using what we discovered in the last slide, write an equation that matches, that is perpendicular. So I'm just going to pick any point here. It needs to, so I know that B of x has to have a slope of negative 2 over 1, which I could just write as negative 2, which is totally fine. And it has to go, it can go through any point. So let's say plus 3, okay? So I'm going to start at 3. I'm going to make my slope go down 2, right 1, down 2, right 1, down 2, right 1. They don't cross at in a perfect spot. And then I'm going to do my best to make this line not crazy, but let's be honest. Hey, that's pretty good, okay? Now, if I put a piece of paper in the corner of that, since this is a square graph, it would be basically a right angle, okay? So this isn't that hard. All I'm doing is I'm flipping the sign and I'm flipping the fraction. Okay, let's take a look at this one. Now this time, they're asking me to find a specific line that's perpendicular. So I need to pay very special attention to the word perpendicular, okay? Because now I've got two different lines that I could be messing around with, okay? I'm going to use, once again, I'm going to use my point slope form because it's my bestie. All right, I'm going to start by finding, actually this is the same line from the last one. Yeah, okay, so I already know line A. Line A is, it has to have a slope of, hold on, what does it say? It has to have a slope of -2 over 1 because we know that line A is A of x equals 1/2 x minus 4, right? So I know it has to have a slope of -2 because it's perpendicular. Next to perpendicular, I'm going to put F for flip, okay? And it has to pass through the point C, which is -3, 4. Has to pass the point -3, 4. So I'm going to do the same thing I did before. I'm going to write that in point slope form. And we've been practicing that. So actually, why don't you write that in point slope for me real quick? Okay, so I'm going to write this. Hopefully I'm doing it right. Y minus 4 equals -2 x plus 3. Then all I'm going to do is convert that thing into slope-intercept form. I could write it in slope-intercept form. I could take it all the way to standard form. Let me do this in math type, actually, in math right. Oh, goodness. Y minus 4 equals -2 x plus 3. I'm going to turn my equiv on because I am definitely, I'm definitely trying to make sure that I know what the heck is going on here. Okay, then I'm going to distribute the -2. Y minus 4 equals -2x minus 6. Okay. And then I need to move my move my -4 over there. So I have y equals -2x. It becomes plus 4. -6 plus 4 is -2. Mathematically, my line should be -2x minus 2. Let's see what actually happens when I follow that slope. Okay, let me get my drawing. So I'm going to go down to right 1, down to right 1, down to right 1. Hey, look at that. I crossed at -2. And if I keep on going, I can draw that. Okay, just pretend that's a straight line. That's the craziest looking line ever. But do you see how, like, I could have just used the point and followed it, or I can do my my point slope form, and that will also get me what I need. Okay, we talked yesterday again about using transformations. Okay, so this time I can look at the graph and see how do I need to transform it. Okay, so there's my parent function. So again, it starts at 3/4. Its slope is -2, so we know that it's going to go through, it's going to be boop, 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 boop. There we go. So our line, how is this line different? Hold on, let me graph it. Oh my gosh, whatever, okay. Well, first of all, I know that it is reflected, vertically reflected, okay. I can see that it is shifted, vertical shift down 2, okay, and it has a vertical stretch because it's twice as steep. So how would I write that? Well, everything is happening outside of parentheses because I don't see anything horizontal happening. So I would say, okay, so my vertical reflection means I'm going to have a -a, so that would be negative f of x. My vertical shift down 2 would be f of x minus 2. My vertical stretch would be 2 f of x. When I put all that together, I have negative 2 f of x minus 2, which looks pretty dang good to me. Tomorrow we're going to do the other 3 slides, so go ahead and make sure you have your notes done, and I will see you then.